أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله تعالى وبركاته. Today our group will present about the topic latest trend on adhesively bonded joint process. Now we will explain to you about how the adhesive bonding works. First, it fastens two surfaces together and makes smooth bond. Second, it is by evaporation of a solvent or by curing a bonding agent with heat pressure and time. And third, it involves glues, epoxies, or various plastic agents. This is the selection factors that we need to consider before we choose the type of adhesive bonding. First, we need to know the substrate material, the biodegradability, the curing condition, the type of adhesive joint, the service temperature, the environmental condition, cost effectiveness, and also the bonding strength of the material, and also the bonding strength of the adhesive bonding. We need to consider all of this before we choose the type of adhesive bonding that we're going to use. This is some advantages of the adhesive bonding: ability to join dissimilar materials, provide design convenience and flexibility. The adhesive bonding will fill the gap and voids in the material, and it provides thin and invisible joint, and the joint may be electrically, thermally conductive or insulating. And also, the adhesive bonding have uniform distribution of the mechanisms over the joint and have good fatigue resistance. But all the things have its pros and cons. So this is the disadvantages of the adhesive bonding. It requires careful substrate surface preparation, and it is long mixing and curing time may be required to make the surface bonded. And it is importance of right joint design. If we design it wrongly, it the adhesive bonding will not working properly. And it is some of the adhesive bonding is difficult the assembly of joint part and change maybe can change the properties during the service.
Now I will continue with the application of adhesive bond. There are many applications in today's world, but here I have selected a few applications to be presented. First, extreme temperature adhesive. Adhesive with a high Tg are suitable for high temperature use, while adhesive with low Tg are suitable for low temperature use. For example, a high temperature epoxy might have a Tg near 150 Celsius, and NRTV silicone suited for low temperature use will have a Tg near 65 Celsius. These are the typical glass transition values of adhesive. Polyamide with a highest value of Tg are suitable for high temperature adhesive. Next, for aerospace. For aerospace, RTV silicone are used to attach the space shuttle. They are used because its durability and weight saving. High temperature adhesive tape. It can withstand the temperature up to 260 degrees in a short term, but in long term, it can withstand only 80 degrees Celsius. Next, underwater adhesive. The idea to create underwater adhesive come up from the muscles. They are be able to stick to surface even underwater. They are using tiny hairs called natural glue containing amino acid DOPA. For example, we can repair the tie underwater, and for marine application, we can use scuba proxy underwater epoxy adhesive for coating and sealant underwater. Next, medical application. For medical application, adhesive bonding are used to repair the wet living tissues and bond. So it can use for orthopedic surgery. As you can see, adhesive bonding also can use for replacing stitches with super glue. So we can skip the stitch removal part, be it slot off along with the outer layer of skin after a couple weeks. I think that's all for me. Thank you.
In this section, we are going to discuss the future trend or future usage on adhesive bonding, which is the self-healing mechanism. A self-healing mechanism can only be initiated when the three components, which is healing agent, catalyst, and the damage itself existed together. There are several testing methods can be conducted on the heal bonded surface. They were tested in terms of their integrity, efficiency, and life cycle. Those tests are fracture tests, fatigue tests, and impact tests. Microcapsule approach. The healing agent and catalyst was stored in a capsule shape. As we can see here, the yellow circle indicates the healing agent, while the widely spread red dot is the catalyst. When a crack forms on the material, the capsule affected will release their healing agent and will repair the surface when it is contact with the catalyst. Microvascular approach. The difference between the microvascular approach and the microcapsule approach is that the healing agent and catalyst was stored in a hollow tube. For the self-healing mechanism to occur, again the crack must interrupt the hollow fiber, and the healing agent and catalyst will fill the crack and therefore repair it. There are three types of vascular network. As we can see, there are first-dimensional vascular network, two-dimensional vascular network, and three-dimensional vascular network. The advantage of having the two-dimensional and three-dimensional network is that the network are a banded network, which means it can repair repeatedly even the damage happened at the same spot again. Intrinsic approach. For the intrinsic approach, it was demonstrated using three main schemes. Firstly, the reversible bonding. The monomeric state of the material will change into a cross-linked polymeric state by an additional extra energy. For the chain re-entanglement, it utilized the mobility of crack faces to entangle chain that span the crack surface. And last, the non-covalent bonding. This system relies on a reversible hydrogen bonding or ionic clustering that manifests as reversible cross-link in the polymer.